Mongoose. A king cobra can drop an elephant with one bite. A mongoose fights king cobras and usually walks away fine, and speed is half the reason why. It baits the cobra into striking over and over, dodging or deflecting each one, wearing the snake down while staying just out of full range, then explodes forward for the back of the skull. One crunch, fight over. But speed alone doesn't explain the mismatch because sooner or later, a hit lands. That's where the second trick comes in. A mutated acetylcholine receptor, the exact site cobra venom targets to shut down a nervous system. In most mammals, the toxin fits that receptor like a key in a lock, and the whole body shuts down within minutes. In the mongoose, the receptor is reshaped just enough that a partial dose barely registers. It's not invincible, a big enough hit can still kill it, but between the dodging and the resistance, the odds flip almost entirely in its favor. Evolution built a lock nobody thought could be picked. The mongoose found a way around it twice over. Honey badger. Ounce for ounce, pound for pound, nothing on Earth is genuinely harder to kill. And its go-to meal happens to be the same venomous snakes that would put almost anything else 6 feet in the ground. Puff adder venom, black mamba venom, scorpion stings, angry bee swarms, none of it reliably works on this animal. Honey badgers get bitten by venomous snakes constantly while hunting them, and here's the part that should be impossible. Sometimes they just collapse mid-fight, appear completely dead for a few hours, foaming and unresponsive, then get back up and calmly finish eating the snake that supposedly killed them. Their skin is loose and rubbery enough that predators biting down can't get a grip to deliver a fatal hold. They just twist around inside their own hide and bite back. Their venom resistance comes from altered toxin receptors. Same trick as the mongoose. Different mutation entirely, though a big enough dose can still kill one. The resistance isn't a free pass, it's what actually built the legend, because it lets the badger walk straight into fights nothing else survives. Lions and leopards do still hunt them successfully sometimes. That part isn't a myth. What's real is that the badger doesn't back down first, doesn't calculate risk the way almost everything else does, and keeps going long after it should have stopped. Nobody's fully explained why yet. King Cobra, the longest venomous snake alive on the planet today, and its preferred meal, oddly enough, is other snakes, including ones venomous enough to kill it outright if the hunt goes wrong. A single bite delivers enough neurotoxin to kill 20 grown adults, or one full-sized elephant within several hours if it goes untreated. It can rear up a third of its body length off the ground and still strike accurately at a moving target. Against almost everything else in its range, that makes it the apex predator, not the prey. So how does it end up on this list at all? Because one animal out there doesn't just tolerate that venom, it resists it well enough to fight back, and we already met it 2 entries ago. The cobra's real weakness isn't strength, size, or reach. It's a receptor mutation the mongoose mastered to blunt the attack, making it one of the few predators on Earth equipped to face a cobra head-on. Everything else, tigers included, just avoids it. Secretary bird. Standing nearly 4 feet tall, mostly legs, and those long legs are the weapon system. This bird hunts venomous snakes on foot, in the open, in broad daylight, no ambush required at all. It stomps its prey to death, delivering a kick with roughly 5 times its own body weight behind it, faster than the human eye can properly track even on camera. High-speed footage shows the strike lands in about 15 milliseconds, while a snake's own physical strike takes closer to 40 or 70, too slow to counter in time. The snake barely registers movement before its skull is crushed flat. The bird's legs are scaled and thick enough to absorb a defensive bite without a lethal dose reaching anything vital, and it strikes from a height the snake physically can't reach, even on the rare occasion it connects. It doesn't outrun venom, and it doesn't resist it biologically at all. It just never lets the fight get close enough for any of that to matter. Meerkat. Small, social, barely a foot tall, standing up straight, and one of the only mammals on record confirmed to actively hunt scorpions loaded with enough venom to kill a human child outright in a matter of hours. The meerkat's trick isn't total immunity like the mongoose. It's partial resistance layered on top of taught technique, and the teaching part is the strange bit. Young meerkats are trained by adults who will deliberately maim a scorpion stinger first and let pups practice the kill on a disarmed, defanged target before ever graduating to a live one. That's a genuinely rare thing in the animal kingdom, the deliberate, hands-on teaching of a dangerous skill across generations, closer to an apprenticeship than instinct. Adult meerkats can absorb a sting that would put an adult human in the hospital and keep functioning. Though it's not painless, stings still cause swelling and sluggishness for a while before it wears off. Combine a receptor that blunts the toxin with a hunting technique drilled in from birth, and you get a house cat-sized animal casually eating things that require hospital anti-venom protocols in people. Opossum. This one isn't fast, isn't aggressive, doesn't even look remotely built for danger, and is famous mainly for playing dead when threatened, which makes the actual answer here even stranger. Opossums produce a peptide in their blood called lethal toxin neutralizing factor, and it's exceptionally good against pit viper venoms, specifically rattlesnake, copperhead, cottonmouth, the tissue-destroying type, neutralizing them on contact before they can do damage. It's far less effective against the nerve-targeting venom of elapids like cobras, so the opossum's real superpower is narrower than it sounds, just extremely good at the one category of venom it's most likely to actually encounter. Researchers have spent over a decade trying to synthesize that protein into a viper-specific antivenom because it's still one of the most effective natural compounds found for that toxin family. The opossum isn't hunting snakes for sport like the mongoose or stalking them like the secretary bird. It mostly just eats them when it finds them slow, injured, or already dead, using a defense so effective it barely needed to evolve any real hunting skill to go along with it. Roadrunner. Famous the world over for outrunning coyotes in old cartoons, its actual specialty back in the real desert is rattlesnakes, and the method is closer to a clean execution than a fair fight. It circles the coiled snake, keeping just outside striking range the entire time, wings fanned out to look bigger and to physically block the snake's angle of attack. Then, it slams its beak straight down on the head again and again in rapid succession until the snake stops moving entirely, sometimes beating the body against a rock afterward just to be absolutely sure it's finished. No venom resistance is involved here at all, none of the biology the others rely on. The entire strategy is pure speed, timing, and precision, never letting the fangs connect in the first place. It's the one animal on this list that wins purely on footwork and reflex, not on biology, built to absorb a mistake if one happens. Monitor lizard. Saved for last on purpose because it flips the whole premise of this entire list on its head. Every animal so far survives venom through a specific receptor mutation or a targeted neutralizing protein, a precise biological countermeasure built for one job. Monitor lizards, particularly the larger species, do something closer to brute tolerance instead. Thick osteoderm-armored scales that slow penetration, a fast metabolism, and a high-pressure, multi-chambered heart that's actually more efficient than most reptiles, and enough raw body mass that a dose sized for a rat barely registers as an inconvenience. They'll eat venomous snakes, scorpions, and carrion crawling with bacteria that would kill most mammals within days, all without much visible reaction at all. Some species also carry mild venom of their own, discovered only in the last 20 years, which raises a question nobody's fully answered yet, whether that's a leftover ancestral trait, an active weapon, or something still actively being selected for right now. That part of the story genuinely isn't finished. By the way, if you're enjoying this kind of thing, I post content like this regularly. I'd appreciate if you subscribed. Thanks. 8 animals, 3 completely different survival strategies. Resistant receptors that blunt venom instead of blocking it outright. Neutralizing proteins that mop up toxins before they can act. And pure technique that never lets a fang or a stinger connect in the first place, all converging on the exact same result. Turning the planet's deadliest creatures into dinner. What's still unclear is why these solutions are so rare. Out of millions of species sharing the same predators and the same venoms, only a handful ever found a way through, and most of them found it independently, unrelated lineages arriving at similar answers without sharing any ancestry to explain it. That's the part researchers are still chasing. If this sparked your curiosity, consider subscribing so you don't miss future animal content.